It's a machine that balances on the leading edge of robotic technology. It's called Ballbot.
What we have right now is basically a novel, unique locomotion platform. The single spherical wheel enables the robot to move any direction. That's called omnidirectionality. Actually one of the holy grails of mobile robotics.
Ralph Hollis is a research professor at Carnegie Mellon University's Robotics Institute. He created Ballbot because he wants to radically simplify the mechanics of robot motion. Because one wheel, a ball in this case, has fewer moving parts. One of the big goals of robotics is to develop machines that can work in our offices and homes. But Hollis thinks current multi-wheel designs are ungainly.
If those robots are going to have arms and head and so forth and be able to really work in ordinary environments, their centers of gravity are going to have to get pretty high. And that means the bases have to be wide, so it's not possible for them to easily go through doorways or around obstacles and so forth.
But what about humanoid robots like Honda's Asimo? Aren't they designed to navigate in human environments?
At the moment, they're very complex and very expensive. So a platform like Ballbot, like we've developed, provides maybe one could say a poor man's alternative to humanoid. A robot that has only one wheel can be made very tall and skinny and therefore easier to have it go through doorways and around furniture.
These days, Hollis is working on ways to make the world's only Ballbot prototype move more gracefully. The robot has tumbled twice because of software problems. The machine suffered only minor damage.
We're very concerned with safety in the Ballbot. It weighs about 100 pounds. If it were to fall over, it could seriously injure someone. Okay, at this point we're going to hold on to the machine and we're going to raise the legs up.
So Hollis acts as spotter to shut the robot down if there are any problems. Hollis's PhD student, Katie Rivar, controls the robot with a laptop and wireless modem.
And Katie can give it a command to start balancing and station keeping. So go ahead, Katie.
Bouncing.
Okay. So I'm releasing it now, and it's balancing.
When Ballbot stands in one place, its computer program keeps the robot's center of gravity right above the point of contact with the floor, moving ever so slightly to maintain balance. When Ballbot moves, it first rotates the ball backwards to make the body lean forward, then it takes off, leaning slightly in the direction of travel. To come to a stop, it leans back slightly just before it slows down, then straightens up.
At the top we have the batteries, which are quite heavy, about 27 pounds. Put the weight at the top, which helps balancing actually. Underneath the batteries we have here a small computer that's very much like a personal computer. It's performing the balance calculations right now as we speak. This gold box is our inertial measuring unit, which contains fiber optic gyros and MEMS accelerometers. That's how we find out the direction of gravity. At the back of the motors are a device that measures the shaft rotation, so we can tell how far the motor is traveling. And then we see the belts go down to rollers. The rollers are pinching this ball. The ball is a hollow aluminum sphere covered with about a half an inch of polyurethane rubber.
Getting this far hasn't been simple. Take the ball, for instance. Designing a durable ball took a lot of work. Then Hollis discovered complicated physics at work caused by indentations where the ball touches the floor and where rollers and bearings push on the ball. This causes drag because the ball takes time to regain its shape, and friction. Both are hard to model in the control program since they change with the robot's speed. It's a problem that Hollis and his team are still working on. In the future, Hollis plans to add arms and sensors to Ballbot to turn it into an autonomous robot. The arms will change how the robot balances itself, so factoring them into the control program won't be easy. but the arms could act as counterbalances.
Much as a person would do if they suddenly ran into something.
Another refinement, a fail-safe program that automatically deploys the legs if there's a problem.
I think the main thing is people should know that this kind of thing can be done, that it's fun. I hope a lot of people want to build Ballbots and make Ballbots and make them work. So we're looking forward to that, to sort of having a worldwide community of enthusiasts working on this type of robot.
It seems when it comes to building robots, Ralph Hollis is having a ball.